All right. Well, welcome everyone, and it's great to be here with you, Adam, and chat to you again. We get together and talk about these topics quite frequently, and it's always a pleasure to get the insights from you and from Futurex. Obviously, your experience in the HSM space is always very valuable to have in these talks. So exciting to have this conversation today.
Absolutely, Paolo. Same here. It's always good to share a virtual stage with you, and we're looking forward to having some good conversations today.
So today's topic is about crypto agility meets post-quantum reality. And really that's about, the advent of post-quantum cryptography and how to prepare for that, how to develop strategies to implement post-quantum cryptography algorithms, and of course, how to prepare your infrastructure to facilitate the introduction of those new algorithms and processes.
Yeah, and so much of what we're going to talk about today is related to preparation. We're not here to say, oh, go do this, you must do that, buy this, buy that. This is about looking at your own environment, looking at the trends that are coming up, and looking at what is happening in the overall payments landscape related to crypto agility, post-quantum cryptography, and really sharing some strategies, tactics, best practices, a little bit of experience from there, from past crypto agility exercises that we've all gone through in the payments industry. So should be a fun conversation. And I know a lot of this will spur future conversation as well. It's a very deep topic. We're going to be really hitting the wave tops for today, but we're looking forward to it.
Absolutely. Well, I think quantum is coming, Adam. And we're at a critical moment in the history of cryptography, yeah. And with the advent of quantum computing, really the cryptography as we know it and how it's implemented in payments is at risk. And this sort of impacts the entire global payment systems and how cryptography is used. Global payments rely almost completely on cryptography for secrecy and integrity of payments. And this is a critical thing. I think, given your experience in the HSM space, can you talk to us a little bit about some of the algorithms that are used and their application in the global payment sphere today?
Absolutely. So when we look at the current cryptographic landscape and we look at the different algorithms that are used in payments, you see a lot of symmetric cryptography, triple DES, AES, but you also see a lot of asymmetric cryptography, ECC, RSA, and that, when we talk about post-quantum cryptography, is really where the biggest emerging threat is going to be. So some of the challenges that are emerging with the advent of quantum computing are weaknesses in those algorithms. And so right now what you're seeing is a move towards transitioning to what they call quantum safe or quantum resistant cryptography, or more commonly PQC or post-quantum cryptography. So there have been a series of algorithms that have been reviewed, developed, and implemented now as NIST approved standards under the FIPS brand, essentially, where these algorithms are designed to be implemented as quantum resistant. So those algorithms have been developed, they've been peer reviewed. A lot of vendors have actually implemented them already, primarily for proof of concepts, for quantum centers of excellence, for things that fall in that more exploratory category. But some of the big questions out there are when. And the timeline question is something that I don't think any of us have a definitive answer for today, but there are some unique things that we can do as a community, everybody here, everybody watching this, to prepare for that. So when we talk about the impact of quantum computing, you look at a few different risk factors. So first off, one of the more important ones that I wanted to cover is what's called an HNDL risk or attack, or harvest now, decrypt later. The whole idea being malicious actors out there will vacuum up all sorts of data and are actively doing that today and storing that away with the expectation that at some point in the future, the algorithms used to encrypt that data can be broken. And so when you talk about when to implement post-quantum cryptography and what the impact of some of those attacks are going to be, that's a really important one to think about. When you look at the payments industry and some things in particular related to key transport, related to communication integrity and security. Those are all areas that, aside from the harvest now, decrypt later attacks, are also going to have some vulnerabilities, and they're going to need to transition. When we talk about when to implement post-quantum cryptography and when that inflection point has to be, that's something that nobody knows for sure. And there are a lot of things that you, as practitioners in the payment security space, need to keep aware of, to follow, to track, to understand as you're communicating, not only with people in this community, but with stakeholders inside your organization and with organizations and partners that you work with. Everybody needs to be moving together. And so one of the things we wanted to talk about in particular is crypto agility and what that means and how the payments industry has really set the stage for a lot of other industries with this.
Yeah, absolutely. So crypto agility, I always get asked what is crypto agility? And I think an analogy to use in this one is basically a car. When you build a car, the tires are not integrated into the frame of the car, that when the tires basically wear out, you've got to get rid of the car and buy a new one. Of course, you want the tires to be a part of the car that can easily be replaced if they wear down. So with crypto agility, that's applying this principle to your crypto infrastructure. It's the same as, you build a house, you've got a door, you've got a lock and key to lock the door to the house. If that lock gets compromised, you want to be able to replace the lock quickly and easily without having to tear down the house and build a new one. Mm-hmm. So that's pretty much the analogy of crypto agility. In a practical sense, what that means is you need to have the ability to change cryptographic mechanisms very quickly. Algorithms, key sizes, you want to be able to adapt fast. Obviously, in the advent of quantum computing, basically there might be a time where algorithms are, broken really quickly. I mean, you've got Shor's algorithm, which essentially renders, RSA useless, and will crack that cryptography instantly. You've got Grover's algorithm, which essentially halves the effective key strength of certain symmetric keys. So it's important that once quantum computing is instituted and once these threats arise, you are able to be agile in terms of your implementation of cryptography. And some of the key points there are interoperability. You need to be able to transition to post-quantum cryptography algorithms seamlessly, but at the same time support older algorithms. So, having HSMs, POI devices support, say, RSA keys that are signed and validating communication mechanisms using RSA keys, but also supporting maybe PQC resistant algorithms like, Dilithium or Sphinx Plus, Falcon, etc. And then, of course, you want to be able to meet the compliance standards at the same time. Of course, when we talk about scalability and compliance, scalability is allowing, so if you have 50,000 terminals out there in the field and an algorithm gets cracked and you need to replace that or a key size, then basically you need to be able to do that quickly. Having a PKI implemented that allows you to deploy keys quickly and replace them on devices out in the field gives you that agility. But if you're using fixed keys on every device and you have to recall them into a key injection facility or something, then of course, there's scalability issues there, cost issues, and a massive time impact that will cause problems there. And of course, if you have that PKI infrastructure, you want to make sure that any deployment of keys is done in a compliant fashion. Obviously, key sizes become an issue there because you cannot transport a larger key with a weaker key. And so you need to make sure that whatever framework you implement, the crypto agility is interoperable, scalable, and compliant.
Mm-hmm. And to build on that a little bit, one of the things that I've always found particularly challenging and interesting in the payments industry is that there are so many different stakeholder organizations out there. It's very rare that a single organization will manage the full loop of their payment ecosystem all on their own. In most cases, there's going to be communication between so many different parties and stakeholders there, and to do key exchange between those, to have interoperability, as you were saying, Paolo, and to be able to have that communication work effectively, you've got to have consistency. You've got to have everybody moving in the same general direction.
Yeah, absolutely. And I think that's why it's important to have robust key management practices in place as part of the crypto agility. I think key management is going to be incredibly important to prepare for quantum computing. So having robust key management practices in place, having the ability to create, distribute, load keys quickly is going to be critical. Also, hybrid approaches. We need to, from a key management perspective, consider hybrid approaches. Make sure that we can use older key management potentially to exchange newer, more robust keys.
I mean, one of the interesting things when you talk about a hybrid approach and an interoperable approach, for PKI, there's actually a certificate structure for hybrid certificate authorities, where within a single CA container, you can embed both a conventional, like RSA or ECC signature and a post-quantum signature as well. So it for the technical folks out there, it uses X509 v3 extensions to do this. And the whole idea behind it is that if you're embedding this certificate in, let's say, a long lifespan IoT device, a satellite, for example, or whatever, you can continue using those existing conventional algorithms for things like code signing, for firmware updates or key transport or whatever, right? And then eventually, at whatever point this quantum horizon reaches us, you can switch over to the quantum resistant cryptography. Maybe that's based on prevalence of quantum computing based attacks. Maybe that's based on interoperability throughout the industry, and when all parties in a particular ecosystem are ready, switch over to that. There are a lot of different considerations there, but I think it's kind of cool that the industry is really thinking about ways to ease the process of crypto agility, and especially in payments, where we've all gone through transitions of algorithms before, triple DES to AES, hashing algorithms, all sorts of things. Learning from that experience and seeing some of the new technology that's coming out to support that, I think is fun, is interesting.
So, what is the role of quantum key distribution going to be in the advent of quantum computing? I think probably will play a limited role, and I'm sure you'll agree. Quantum key distribution is essentially distributing a key using photons instead of mathematics. So I think when people hear QKD, they think about, well, this is going to be some encryption mechanism that's going to help us distribute keys. But that's not actually the case. It's not actually involved in any type of encryption. It's just a mechanism used to communicate a key to a third party, not even in a secret way, but basically in a way that it's impossible to not know if someone has observed the key. I think the analogy that we can give is basically, since you're using photons to essentially beams of light to distribute data that is essentially communicating the key, it's like me blowing bubbles to you, and if someone were to touch one of those bubbles, it would pop. And essentially then both you and I would know that someone had observed or tampered with this data in transit. Someone observing those photons essentially would change the data, and ultimately we would know about it. And I think at the moment there's a huge amount of limitations. There's specialized equipment needed. I think current fiber only supports communication over a couple 100 kilometers. So implementing that at scale, especially when we're looking at the global payment system, is probably something that is quite far ahead.
Yeah, it's going to be interesting when we go back a few years from now and relook at this and what we're talking about here to see really what has changed and how some of these statements kind of hold up. And what we wanted to talk about next is AI's influence on post-quantum security. And AI, it's an incredibly hot topic right now. Everybody wants to talk about it. Everybody's thinking about how it's going to impact their day-to-day life, their jobs, the role of our security practitioner ecosystem here. It's all going to be heavily impacted by it. And it's not our place here today to speculate on a whole lot of that because we don't know. But it is important to note that as related to post-quantum security and where crypto agility is happening and continuing to be a really important principle, AI can be a really valuable tool to help with that. There are some risks to it, obviously. There are some benefits to it. And I think, like everything else we've talked about today, it's important to keep abreast of the latest changes, the technology, be aware of what's going on, and find out with that if you can use it to help your own deployments, if you can help your customers with their post-quantum journeys, and use it as a tool, but also be aware of some of the obvious limitations of it.
Yeah, I think the use of AI, at the moment we see more in sort of analyzing metrics around cryptography, looking at key synchronization errors, AI reporting on those errors, kind of spanning a payment network of some kind to identify weaknesses in algorithms, etc., and report on these things to then help entities, that have crypto agility implemented, change keys or key sizes, algorithms, etc., where it needs to happen. But I think an interesting idea to explore as well is, what is AI's function going to be in terms of research on a quantum computing level, and will that speed up the process of the advent of quantum computing?
That's a really, really, really good point, and something, it's kind of a fun thought exercise to imagine. But imagine if AI is developed to such a state where it's capable of doing research on itself, capable of self-improving. Now that to us sitting here right now in 2025 may sound far-fetched, but I don't know. Is that going to seem as far-fetched in 2026 and 2028? We really don't know. And the last few years have seen such a dramatic and fast change in society in general as it relates to AI that we would be remiss if we didn't consider it as a potential kind of X factor that could dramatically speed up the timelines that organizations need to think about implementing post-quantum cryptography.
Absolutely. Well, what do organizations do next?
Yeah, this is interesting because there are a lot of organizations out there that'll say, here, go implement these algorithms, go do this, go do that. Personally, my opinion here is it's a little bit soon to start actually using these quantum resistant algorithms in practice. It's good to get out there and see what's available. It's good to understand the lay of the land. But if I could recommend something, one takeaway for everybody watching this is first and foremost, understand what's going on in your own organization. Go back and communicate with your own stakeholders, communicate with trusted advisors who can help you in this journey, and understand where you're using cryptography currently throughout your organization, not just in payments, because this is going to be very wide-ranging in its impacts. So understand where you're using cryptography, and also understand what your level of crypto agility readiness is. Go back, if you've been there for a while, or if you've got people in your organization that are those institutional memories who maybe bear some of the scars from prior algorithm transitions, go back and talk to them and understand what some of the challenges they faced were, understand key takeaways from that, and if there are any things they can do to make the process easier, and just really understand what you have ahead.
Take stock and do a risk assessment. Ultimately, is what needs to happen.
Yep.
But I think in terms of the next step, really it's to adopt crypto agility. Get your infrastructure to the point where you can adapt quickly, not necessarily to implement algorithms, PQC algorithms immediately, but just get agile, and then you can usher in changes seamlessly and easily. And we know that's difficult in payments because when you change crypto keys here or an algorithm there, usually the system stops.
Yep.
So it's about getting systems to a place where that doesn't happen. All right, so I think the final takeaways and conclusions around this is really that quantum computing is coming. A first step in the right direction is to become cryptographically agile, implement crypto agile processes within your organizations so that you can adapt quickly. QKD is probably not something that is going to be a factor in the near term, but certainly AI is something that could be, and is something that needs to be looked at least from a monitoring perspective. And I guess, migration needs to start now, certainly to more cryptographically agile infrastructure, for sure.
Absolutely. I think the time to start planning is now. The time to start doing those internal investigations and studies is now. The time to buy stuff for it, I mean, as much as I would love to say yes, that's probably not the answer, right? The time is now to, like Paolo said, to get ready and to make sure you are crypto agile. Because ultimately, quantum computing is going to bring massive change to the industry, but it's also not the last time we're going to see algorithm transitions. Absolutely. And so what we're saying here is prepare yourself this one time, but do it in a way that's sustainable over the long term, because there are going to be more instances where it's necessary.
Yeah, absolutely. Thanks for those final thoughts, and thanks everybody for watching.
Thank you.